So we're going to start section 3, evaluating logs. And so this is essentially going to be saying, so log base 4 of 64, what's that actually equal to? What is that? Is that 10? Is that 1? 3.5? What is that? So we're going to be able to solve that. Evaluate that. Later on, we'll, I think in the next lesson, so the next lesson will start on Wednesday, we're going to do a little bit more of a deep dive into how you can use logs to solve exponentials. So we'll get into that a little bit later. But today, evaluating logs and doing some of those, some log properties that we'll do. The first thing I would do is equal to x. Really, it's the same thing as if I would say 6 plus 4. Evaluate that. You guys would all say, well, that's equal to 10. So it's kind of the same thing what we're doing. But for our purposes, if we put an x there, that's going to make it easier for us to keep that as a placeholder because we're going to put it in exponential form. That way we can solve it like we did before. So exponential form, remember that's what we did on Thursday before we had our long weekend. That 4 is your base number. The x is your exponent, and that's equal to 64. So what number is 64? Now, there's actually a couple different ways to think about this. I guess I should say there's a couple of approaches, but it's all the same way. If you have an exponent sheet, I always start with saying, especially this one because it's just an x. 4 right here. Just draw this. There we go. And 4 is it on there, and this one is 64 is right here, so now it's got to be 4 to the third. So 4 to 1, 64, 3. No different. How can we make 64 have a base of 4? So you use your exponent sheet and see that it's 4 to the third, and then you set your exponents equal to each other. Again, they're really identical. They're the exact same way to do it. There's kind of a different way to think about it, I guess. Either way is fine with me. I don't care. Like I said, they're legitimately pretty much the same idea. So number 2, same thing. This is going to be equal to x. So 9 raised to the x is equal to 243. So again, I go to the exponent sheet. Raised to the x is 243. If you look, so if you go down the line with number 9, there is no 243. So I start with number 9, I go down the line, it gets to 729. Obviously, it's just going to get bigger. So there is no 243. So this one, we have both of our bases. Well, 9, and again, if you want to look on this list, 9 only shows up here once. So hopefully you guys realize 9 is 3 squared. Again, if I give you any of these on the test or quiz, it's going to be something that's pretty common. Like 25, you guys know is 5 squared. At the most, I'd maybe do 8 is 2 to the third, but probably not. But 9 is 3 squared. So can I use 3 to get 243? Yeah, that's over here. 243 is on that list. That's 3 to the 5th. I can change 9 to 3 squared. I can change 243, we just said, was 3 to the 5th. So multiply your exponents. That's 2x is equal to 3 to the 5th. And then set your exponents equal to each other. 2x is equal to 5. X is equal to 2.5. Again, make sure you show your work on this because I know some of you guys can just use guess and check and eventually stumble on the answer. I understand that. But also, again, sub your answer back in and check at least to this one. Because, I mean, put in your calculator 9 raised to the 2.5, and it only takes 2 seconds to see if you got that right answer. I should give you that 243. Couple more here. Now this one looks a little bit more difficult because we have 1/8. We have a fraction. 2 is equal to 1/8. The big deal with fractions. First off, if you have 2 raised to a fraction or any as a fraction, I know that's going to be a negative number. So right away, whatever your x is, it's going to be something. You're going to figure that out is just like your denominator. 2 raised to what number would be 8? And if you don't chart, This whole number would be 8, that'd be 2 to the third. 2 to the third is equal to 8. To get 1/8, instead of 3, it's just -3. So x equal to -3. So again, it's the same thing. Whatever number would be your denominator, whatever bottom number, it just makes it a negative since it's 1 over that. And just really quickly, following that pattern, if I had 5 to the -2nd power, it'd be 1 over 25. 10 to the -2 would be 1 over 100. And that is one that a lot of people miss. To the -2nd. 5 to the -2nd is a fraction, 1 over 25. 5 to the -3rd is 1 over 125. Anytime you have a negative exponent, that makes it into a fraction. Okay. Sorry, let me clean this up a little bit. And last but not least, one we talked about the other day, we just have log of 1,000. Remember, if there's no base number, that's a base of 10. That's pretty much the reason I added this on there. So we have 10 raised to what number is equal to 1,000? Now, here's a little fun fact. The number of zeros that go with that second number, the 1,000, that's what your exponent's going to be. So 10 to the third is 1,000. So x is equal to 3. And I always used to get confused about that in high school. I don't really know why. But the thing I always remembered is you guys all know 10 squared is 100. Well, 100 has 2 zeros. So whatever that exponent is that number. I actually know why that confused me, but I'm not going to tell you because I don't want to confuse you. Okay. So on your own, go ahead and do these 3 problems. Shouldn't take too awful long. By the way, today we do have a win exit ticket again. Like I said, we're going to have that for this week and next week. After that, then I'm going to try to focus more on what your grades are. Again, number 5, if you wanted to add that step where you had 5 to the x equal to 5 to the third, and then you set your exponents equal, that's fine. I'm okay with that. Again, there's only one step like that. You have your exponent sheet especially. You can just say 5 to what number is 125? It's 3. 16, again, that's an example of you have to change both of those bases. But like I said, the big thing, or sorry, number 6. The big thing is I put number 16. The number 16 in there because again that's 4 squared. That should be a pretty common one. You see 16, you guys hopefully are thinking, oh yeah, number 16 is 4 squared. So I try to give you that start. That way it's not anything like too outlandish. I've had problems in the past where there's several different options and that gets confusing. So not saying that you guys can't handle it, just saying that you're welcome. Any questions on those before we move on? I like those problems because it's actually getting a form to exponent form. We did that in the last section. And now we're solving it once it's in exponent form. We also did that in the last section. So it's kind of a big everything combined from the last section, which means it's also a lot of review, which is kind of nice. So the next thing we're going to look at is a couple of these different properties of logarithms, and there's really a lot more than this. These are the main ones we're going to focus on. And I tried my best to show you, and maybe you guys don't remember this, or maybe it's like by this point it's kind of, you do it without thinking, but I related it to the exponent properties. So again, exponents, inverses, logarithms. Sorry, just wanted to check that because inverses of logarithms, so they really kind of have the same properties. So the first exponent property, if you're multiplying and you have the same base, you can add your exponents. So b to the m times b to the n is equal to b to the m plus n. Now, for the logarithms, I actually wrote it the other way around, where you're adding them and they have the same base, you can multiply. Really, obviously, with an equal sign, it doesn't matter which way you write it. I used to do it the other way, so it mimics the exponent property. I'd say that if you multiply, you can break it up. But we don't use it that way very often. We use it this way a lot. So it makes sense with exponents being the inverse. With exponents, usually when we're multiplying, that means we add our exponents together. Logarithms are the opposite. When we're adding them together and they have the same base, that means it's multiplication. So what we'll do down here is simplify it as writing it as a single logarithm. Occasionally we'll write it as a single logarithm and then evaluate. So what I'm doing. But again, it obviously goes both ways. Whether you're adding to make a multiplication or multiplication makes adding, doesn't make any difference. But the way we use it is how it's written up there a lot more. Now, probably pretty obvious, division is the exact opposite. Again, with the exponent property, it said that if we are dividing and we have the same base, that means we subtract our exponents. The logarithm property, that's the exact same. I just wrote it the other way around because that's what we're going to work with more. If you are subtracting, that means you can divide. Now, again, provided that the bases are the same, that is kind of a big deal. And then the last one, I don't know actually what this is called necessarily, and I'm sure we could figure out an exponent property that mimics this, but we just don't use it very often. But the one we will use a lot is this property here that says if you're multiplying, so if you have a number out front and we're multiplying that by log base b of m, you can actually take that n and put it up here as the exponent with your m. So if you have a number in front that's multiplying, you can move that up to make it as an exponent. We will use that a lot more, not on the quiz, but in the next lesson. Again, using logarithms in our calculator to solve exponentials, we'll do that property a lot. That was one of those things I've taught this class before where we only just want to go over the basics. So we talk about that and then we don't go further than that. And I think that's a disservice because that property you don't use very often unless you go to the next step when you're using that to solve. So looking at those three, simplify, make this a single logarithm. Number 8 is a single logarithm. We're asking you to do that exponent property thing we just talked about. We'll get to that in a second. So it's important to realize they're both the same base. If they're both the same base, that means we multiply. So this is just log base 7 of 2 times, which is log base 7 of 18. Don't make that harder than it is. Again, at this point, in my opinion, it's more of a memorization problem. And the good news is, not only do you guys have done the exponent properties, so hopefully that helps, but for me, it kind of makes sense where multiplying kind of goes with adding and division kind of goes with subtraction. Base 3 of x. Again, we have a number up front that's multiplied, so you take that number up front and put it up as an exponent. So it's actually log base 3 of x to the 6th. Now, the reason that property is also really is because if you look at this number 9, we can't do anything with that. We can't add those together because we have the 5 and the 3. So at the first glance, we have adding. Adding needs multiplication, but we can't do it because, again, we have that 5 in front and that 3. So before we do anything, we can get rid of those numbers in front by putting them as exponents. So that 5 goes up, so this is log. If you want to put base 10, it's not a bad idea. If you remember that and you are good enough at math that you don't have to worry about it, then you don't have to. When I was in high school, I definitely either wrote it or should have. And then same thing with x, and that 3 goes up with your exponent. So that's log base 10 of x squared raised to the 3rd. So now we can start chipping away at this one to make it look a little bit nicer, to make it a single logarithm, like they've said. We have x squared raised to the 3rd. That means it's to the 6th. Now we're adding those together. So we're adding, we can multiply. So that's log base 10 of x to the 5th times x to the 6th. Which now it's kind of ironic because now we're going to end up using the other exponent property we just talked about. Log base 10 of x to the 11th. When you're multiplying x that have the same base, so we have exponents. So that's one of the reasons I like that problem specifically. We cover a lot of different things, including doing that exponent property as well. So, shouldn't be too bad, but that said, there is a lot going on in there. Again, I wrote it up here. Make sure you get those exponents up there first. If you have any numbers in front, make sure you make those exponents before you do anything else. So, moving on, using these to actually solve. So this one we have log base 2 of 160 minus log base 2 of 5. What's that going to be equal to? Now, I will tell you there's two separate ways to do this. You find out what log base 2 of 160 is. That's going to give you a number. What log base 2 of 5 is, that's going to give you another number, and then you can just subtract those two numbers. Numbers are going to be decimals for this one. Sometimes they work out nice and evenly, but 2 raised to what number is 5? It's going to be a decimal. Technically, you could do it that way. There's something that we probably won't have time to go over called the change of base, where you can put that in your calculator and actually find out the exact decimal. But again, I think it's easier. Go ahead and do that property first. Once we have that property, then we can evaluate. So again, technically, you can calculate first. I think it's easier to simplify everything out to a single logarithm than evaluate. So this is going to be log base 2 of 160 over 5. 160 over 5, put in the calculator. Log base 2 of 32 by evaluating like we did earlier today. So 2 raised to one number is 32. And again, now you can use your exponent sheet. 2 raised to the 32. Sorry, 2 raised to one number is 32. That's the fifth row. So 2 to the fifth. This is always the internal battle where maybe I should do one more lesson and actually go over and change a base formula, but actually, if we're being honest, that's one of those things. I think the change of base, not that you actually care, but my calculator, I have to do the change of base formula to do any of those in your calculator, and I'm willing to bet that the newer calculators, there's just a place where you can type in log base 2 of 160. There should be. I can't figure out how to win. Anyway, so the next one, same thing. We are adding together, so it's multiplication. So log base 6 of 27 times 8. Is 216. So that's log, whoops, log spelled with a 2 instead of an L. Log base 6 of 216. So now, again, this is where now I simplify. So 6 raised to the x is equal to 216. Exponent sheet, go down to 6. Here, so that's in the third column. So 6 to the third. So your x ends up being 3 for that one. And again, just so you understand what this means, if you take log base 6 of 27 plus log base 6 of 8, that will give you 3. Which again, make sure you're showing me your work because like I said, I'm pretty sure your new calculators, you can figure out a way to type those in. So make sure you're showing your work. If you want to use the change of base formula and use your calculator instead, honestly, you know what? If you are going to take it upon yourself to learn that on your own, show your work, I'll give you credit for that. It's probably more confusing for a lot of people. So go ahead, do these last two on your own. Once you're done with those, we have about 20 minutes left. So once you're done with those, work on your exit ticket, the win exit ticket 10.3. Like I said, I'm going to be using that to sign people out. Since we do have 20 minutes, you do need to finish this in class. So please make sure you're doing that. I'm going to probably do the same thing I did before, where if you're sitting in class and you don't get that done, make sure you tell me if your computer's broken or something. But if you're in class and don't get that done, a lot of times at the end of the day, I unassign it to you so you can't do it. Because again, if I'm going to give you 20 minutes to do this, I'd appreciate if you took the time to actually do it. But if something happens that you can't, let me know. I am very understanding, unless it's that you're not doing work. My answers are up there. Couple things with this. Number 13, 4, there is no 4 raised to any number is 128, so you have to change the 4 to a 2 squared. The 128 is not actually on your list, but it's really close, so I just did trial and error. 2 to the 7th is 128. Then the other thing that's interesting really quickly, and don't worry about it, but there is another property I didn't really talk about, where if you have the same number here, it's just 1. So log base 3 of 3 is always going to be 1, and it's for that reason, because if you put the exponent, 3 raised to the first is whatever, is 1 number. And same thing, this is actually one that we won't talk about at all, but if you have the same number there, but there's an exponent, your answer is going to end up being that exponent. And again, it's that same reason. I'm not really going to go into it, but just interesting fact. So there are a couple other properties of logs that we don't talk about, but really those properties are just shortcuts to the property we just talked about. Oh. Yeah, no, I see what you're talking about. So sorry, 13, I did not see this log 2 in front, or this 2 in front of that. So that changes things. I'll change that real quick. All right, I apologize. That does change a lot. So I just missed that 2 in front. Honest mistake, going too quickly, so we'll act like I did it on purpose for my self-esteem. Put that 2 out as an exponent, so 2 squared is 4. So you have log base 64, or sorry, log base 4 of 64 plus log base 4 of 4. Now the bases are the same. It's adding, so you can multiply those. That gives you 256. Then if you change it back into exponent form, 4 raised to what number is 256? It's 4 to the 4th. Hopefully that is correct. So make sure you guys still have about a little over 10 minutes. Exit ticket if you have not done so. Like I said, there's 3 questions. Shouldn't take too long. If you have any questions, let me know.